Hey there. In this video we're going to be removing the distributor on our Suzuki Samurai and replacing it with an electronic system. This has a few advantages. For one, it sets it up so we can use fuel injection in the future. It gives us a lot more precise control over the timing and a stronger spark. And last but not least, it allows me to actually run my Samurai since I destroyed my distributor earlier last year by screwing around with it. We have a few magic important pieces to perform this. Firstly, and most importantly, we have an ECU unit. This is a Microsquirt with an 8-foot long harness. Plenty of room to do other things other than just the igniter. Fuel injection, boost, all that stuff can come later. We have our Bosch wasted spark igniter unit. This is a 0986221048 from a Volkswagen. Should work just fine. And another very important piece is our timing wheel and our Hall effect sensor here. We'll be mounting this likely with some bolts to the oil pump. We'll figure it out for sure when we get to it, but this will tell the ECU exactly where the camshaft is, where the pistons are, and when to fire our spark. Let's get to it.
Alright, so the first step of this process is to remove the distributor. We're not going to be using it anymore since we're going to have a computer controlling our timing. It's easy to take off. You just use a 12mm wrench and you take that little bolt off you see right there and this whole thing pops off. Easy peasy. So now that we've got the distributor out of the way, the next step is to remove the distributor housing here on the back. It's held on by 3 bolts. The reason we're going to take this off is so we can trace this flange right here and make a block-off plate for it. When you're taking this out, you might want to have a couple of rags down there to be prepared to catch the oil. There we go. That's not too bad. Alright, so the basic idea is to place this down on this plate and then use that marker right there to mark around it, and then we can then use that as a guide to cut it out with a jigsaw. Okay, so there's our basic markup. Alright, so a few minutes at the bench grinder. Turn that rough shape that we cut out with a jigsaw into the nice smooth shape we were after. And it fits quite nicely. Alright, the next step is to clean this gasket off we built. Clean both the mating surfaces. We got us a little smaller bolt because the other one was too long. Didn't want to thread all the way through. And we got some ultra gray gasket maker right here, which is frozen up here, so I'm going to have to just get it like this. So we're going to put this down here, put a nice little bead all the way around it. The goal here is just to make sure that nothing gets in here. Doesn't have to be thick. A little bit goes a long way. It's pretty good there. A little bit of thread locker, glue. It means you can actually get it loose if you need to, but it holds things in there really well. Just put a couple on the threads, a couple drops. That's definitely enough. Alright, here we go. We got our distributor block-off plate built and bolted on with some gasket maker on there. It looks pretty good. It'll certainly do the job. Alright, so I made me a couple of iterations of a mounting plate for my igniter, and this is what I ended up with. It's just got a little angle right here, and this mounts to where the coil used to be, so it's going to go just about right there. So my igniter will be hanging around in this area. I wanted it to keep it more on the cool side, but there isn't really a good location to mount it over there. It's not too bad, at least it's more in the center, it's not sitting right here. All I need to do now is drill some M6 holes right here for the mounting, and mount the coil pack right there. Should turn out pretty good. Okay, so the next thing I need to do is build a bracket for the Hall effect sensor so it can read from the trigger wheel. And I've been looking at it for a few minutes, and I think I have an idea of what we can do. The trigger wheel is going to go on top of that pulley right down there that attaches to the crankshaft. And I have a few areas down here that are free that can take some threads. So I got right here, and these two down there. I think what I can do is build a simple bracket out of some aluminum stock I have, and we'll go from here and extend out to about there. And I can attach this to that bracket somewhere about like that. Alright, so here's the template I drew out. Here's our mounting plate completed. We drilled a couple of holes in the back, one for the wires and another one for the mounting. I still have to drill 2 holes here to attach to the block. Okay, so it's time to install the trigger wheel. To do this, we're going to loosen the alternator so we can get the belt off, and then we're going to take the crankshaft pulley off. Crankshaft pulley is held on by 4 10mm bolts. Shouldn't take too long for us to get this done. Let's get to it. Alright, now for one of the more critical pieces of the puzzle. We got to figure out a way to mount this trigger wheel to our crank pulley. Now, the Suzuki Samurai, of course, was not fuel injected, at least not the 87 model. So it doesn't have any natural, easy way of mounting this to this. There are a few methods, I guess, you could go about doing this. One would be tack welding it, but I'm not going to be using that method. I'm going to build a simple bracket using a 1/4 inch aluminum to get this to mount to here. So the basic idea is this. I measured it out. This is 2 3/4 inches exactly. I found that that corresponds to a 2 7/8 hole saw. Remember, the hole saw, the diameter of the hole saw includes both the interior and the exterior of the cut, but there's wasted space. So you have to go a little bit higher in order to get it to fit perfectly. Now I've cut a couple of these out, and they fit down in there pretty snug. You know, there's not too much movement. It's enough for me to be happy with. So I'm going to cut 3 of these, because the distance from this innermost piece to be flush with the outside is also 3/4 inch. So 1/4 inch, 3 of these, we've got 3/4 inch. It'll stick out there and be even. That means this can now sit here, and it can mount flush. And I'm going to do that by drilling holes. These are the holes that attach this to the crank. I'm going to drill it through here and through the bracket. I'm going to have to drill a couple of holes in the trigger wheel because these slots don't align to make this set up properly. We'll show you that a bit later. And lastly, we're going to have to cut a pretty big hole in the center here because the crank nut needs to fit through it. So at least through the first 2, there's going to have to be a pretty big hole that way that will sit through there. And then I'm going to use JB Welds, squeeze these all together. So this bracket will be attached to this. Then I can put the oil pump pulley, it's not the oil pump pulley, the crank pulley, in place. And then I should just be able to set this in there, put my bolts in there, and it should work. That's the idea anyway. maple mixtures. Putting the nuts and bolts on here, tighten it up, and that should set overnight. Alright, let's see what we got here. We let this set overnight, and it glued together, or bonded together real nicely. Give us a nice solid mounting point there. I drilled a hole straight through the center and attached a 10mm bolt and put the nut on this side. There's a lock nut, a lock washer inside of here. The main reason for this is to give me something I can use to turn the crank over when this is attached. If I didn't have this here, then I wouldn't be able to turn the crank by hand if necessary to set timing or whatnot. One other thing I did is once this was attached, I sat this down, measured all around it, making sure that it was as close as possible to even around through here, and it was. It's about 2 and so many inches. Actually, we'll just do a quick test here. It's about just a little over 2 inches, a little under 2 1/4, all the way around. And this is pretty important because we're going to have a sensor just a couple millimeters away from this, and if this is any more than the distance that is away, it will be lopsided and hit the sensor. But it looks like we're going to be okay. Attach this on here, drill a hole straight through here, because these mounting points didn't align with the wheel. And the way this has got to work is this first tooth right here, after this gap, needs to align to this little mark right here, which indicates timing. In our purposes, this would be top dead center. So when I have this lining up directly with this, these slots that are already cut did not line up with the holes. So I had to cut a hole, cut it through there to make it work. So now it is lined up perfectly. So all I have to do now is mount this to the crank, and we should be ready to go. Okay, so surprise, surprise, we've already run into a problem. This bolt that I have attached in through here actually extends too far out. And this hole was cut out so the crank bolt will be able to fit through there. It's pretty big, and it needs to fit through this space. However, this extends out into the space where the crank bolt is, so I can't get this whole thing on. So I'm going to have to remove this and either get a smaller bolt on here or enlarge in the center so I can get a ratchet if I want to be able to turn it over by hand in there. So think about it, we'll see what we'll do here. What I ended up doing was removing the center nut and bolt. It was just too large and would not allow it to connect onto the crank because the crank bolt was poking out too far. I found that I can actually just stick a long screwdriver or wrench in between the bolts I have down in there now and get it to turn if I need to. So I went ahead and bolted it up like this. So the next step is to finish this little bracket out here. And what I'm aiming to do is I could either cut another piece to move this out this distance, because when this is attached on this side it hits against the crank, the trigger wheel. So I'm going to cut this section off right here and mount this back here facing this direction, and that would give me just the right amount of space in between the wheel, and hopefully it will read okay, and then we can begin wiring all the stuff up. Everything looks to be lined up okay. I spun this over by hand using that wrench between the bolts, and it doesn't hit anything, so we should be pretty good to go. Now we're finally to the steps of putting in the Microsquirt, or in this case the Microsquirt. we're going to install it where the previous ECU was, which is right up here. I'll have to get some spacers to make it just right, but it'll fit there. I ran the wiring loom through where the previous ECU loom was. It actually still is. Right there. It was a bit of a pain to get through there. I'll tell you the easiest way to get it out is to tape up the ends to a nice point, and you can just push it straight through there nice and easily. Okay, so I bundled up the wires that we're going to be using and the ones we're not going to be using. Since the only thing I'm concerned with right now is running timing, we're not going to be using most of the inputs or outputs. I mean, there's so much flexibility in this little thing. But we're only concerned with a handful of wires, really less than a handful. These right here, 2 black wires, if it will focus, there we are. These go to the engine block or some kind of ground. It recommends the engine block, so that's what I'll be using. These 2 right here, this white one and this one that looks like a candy cane, these go to my ignition system. So these will actually attach over to there. And these 2 guys, these other 2 black wires with little white stripes down them, these go, these are a sensor ground, so anytime we attach a sensor we should attach it to this. Microsquirt documentation recommends that to make sure that they have a solid reading. If they don't, if there's a high current pull, such as during turning the engine, it could cause them to not read out properly. And then finally we have our VR and VR2s. Alright, the next step is to provide switched power to the Microsquirt. And what that means is when the key is turned on to turn the engine over, or when it's running, the Microsquirt should have power. And it's important to understand the types of different key states here. Let's see if we can get this looking at it. Alright, kind of blurry. This state right here, which it says here, most likely you can't read it. It says ACC. This is for your accessories. So this would be where you would want to power your radio, and right now a few lights are on as well. Now the next, in this state, the next state over, this is your running position. You turn it one more and that begins cranking the engine. You let go, it goes back to this position. So what I need to do is find the wire on the ignition that is powered on when in this state. And I've already got it figured out here. The wire, got a ground right there to my trusty meter. It's reading 11.72 volts. That's actually a little bit low. I'm guessing there's somewhat of a poor ground somewhere, or it could just be an old wiring harness, or it could be that the ignition switch itself has less than ideal contacts. I took it apart and cleaned it, but it could be any of those things. The wire that it is this black, there's a black wire with a white stripe, and I have it attached up at the very top where it is soldered onto the connector. This wire goes right here. So what I'm going to do, it's this wire right here I'm pointing at. This black one, the white stripe. This camera doesn't like to focus. So what I'm going to be doing is stripping this right here, stripping the shielding off. I'm going to clip this wire, solder on another wire, heat shrink these back together. So I'm going to have basically a wire teed in to this. So when it's turned on, or when I'm cranking the engine, this will have power. See, I'll show you that we've got power and we're also cranking, and that's vital. We've got 11.6 volts. It'll do a sharp drop and then stay up. See, we got power when we're cranking, and also when it's in the on position, which is exactly what we want. Now, the Microsquirt right here is attached to a relay, and the reason why we're going to power the Microsquirt from a relay is because, as you've seen right here, we've got less than ideal voltage. So this is being powered from a relay that is connected straight up to the battery. So we have a solid 12.7 volts right here. I want to make sure that the Microsquirt is going to be powered properly. So we're using a relay to make sure we have nice clean power. This right here is fused. It's a 5 amp fuse running to the Microsquirt. We're going to run that wire that we're going to attach under there straight over to here, and it's going to attach right where this red wire is. Right now I have it connected to something else, but it's going to attach right here. When I turn that key on, it will flip this. It will pull nice clean power from the battery, and it will turn the Microsquirt on, and I'll also start fiddling with it. So let's get to it. This is our TN wire. He gun. Alright, now we get to see if our connection is functional. To do this, we have our Microsquirt hooked up to this RS-232 cable to a USB adapter onto my old machine here. We're going to load up Tuner Studio. Alright, so it says it's not connected. As soon as I turn that key past the accessory position onto the on position, that should flip on and we should get power. Right now we just have it kind of hacked in there to make sure that this is going to work. Let's flip this and see what we get. Nothing. Why? Okay. I wasn't expecting. I know why. I haven't plugged it back in. Oh boy, that was a moment. Let me plug this sucker back in. Yes, you've got to go back in there to function, don't you? Alright. So in the accessory position, onto the on position. Hey, check it out. It is now reading it. So that works. That works excellently. So while I'm here, I should probably go ahead and tell you that it's very important to ground all your unused sensor wires to the sensor ground. I got one of these things off of Amazon. They came in a pack of like 8 of them for $12. It's basically a bus bar. And these black wires on the ends are the sensor grounds, and all these other ones are the sensors I'm not using. What this does is it prevents the signal from floating. So if I didn't have these attached, it would be thinking the mass airflow sensor or the throttle position sensor would be like wide open or some random variant thereof. This makes sure they're grounded so the Microsquirt knows what it's seeing. Okay, so now that we're actually we are hooked up, let's flip this around, turn the engine over, make sure that the Microsquirt retains power while we're rotating the engine. That's the next fun step. Alright, that should remain online. Perfect. Now that we have our Megasquirt, or our Microsquirt to be more exact, connected, and reading with our computer. The next step is to get this Hall effect sensor down here, which I bought from DYAutoTune, connected and working properly. So I followed the documentation, and red is power from the switch, and that's either a 5-volt signal or a 12-volt signal. So I decided to get a 5-volt signal running from this VREF line right here, which is typically used for a throttle position sensor, if I understand things correctly. But I'm not going to be using one right now. So I've got this attached here. Notice that I haven't done any crimping or soldering yet. I'm just testing to make sure this is actually going to work. So this provides a 5-volt signal. Black is sensor ground. So this yellow wire attaches to our sensor grounds here and goes over there to the black wire. And this white with the black wire is our signal wire, which needs to connect to the VR1 negative, which is the green right here. We should get a signal when we turn the engine over. So what it says to do is to go to diagnostics and high-speed loggers, like so, and hit the start button on the composite logger, and to crank the engine 10 to 20 seconds. And we should see little, like a graph appear, and each bar on a graph, if it shows up, indicates a tooth that's passing the sensor, the Hall effect sensor. Let's see what we get. Hey, look! That's surprising. Looks like it's actually reading it. So there's different pages down here. I'm going to go back, forward. There we go. So that turquoise line indicates that we are getting a signal. Red means that it's a sync loss. So this is like during initial cranking. Tooth logger mode now. Started. Let's go. That looks accurate. Stop that logging. This is logging on, okay, 250 milliseconds. It makes a page. It's probably not long enough. Let's switch this to be 4,000 milliseconds so we can get a better page there. Start it. Smell gas when I've got this cranking. Alright, that's more like it. So, you know, this is really surprising to me, but that looks like a good signal. It looks like what I would expect based on the manuals that I've read so far. So there should be 35 lines, including this long one between this long one and the other one. This long line indicates top dead center, and these other ones are each tooth as it passes, it creates a pulse, and the Microsquirt picks it up. We only have one spike, which is what we need. If we had two or more, that would be a problem, so we've just got one spike. This one after is a little high. Shouldn't be bad enough though. Well, I think the signal's clean enough to hook up the ignition coil. Now let me show you the ignition settings I've got this set at right now. So you get ignition settings, wheel decoder. So I've got to set it to a tooth wheel, and most of the other stuff is just defaulted. Okay, the tooth 1 angle is set to 270 degrees. That means from top dead center, if you was to go counterclockwise, 270 degrees, that's where the sensor is. Okay, now that I know this thing's hooked up correctly, the next thing I'm going to do is remove these temporary wires and actually install a nice 3-wire pigtail here. Alright, let's show you what we got here after we got everything nice and soldered up. This is our pigtail. Our other end, right here, goes straight down to our sensor. And there's a little bracket down there that we have it going through, that way it won't get in the way of any moving parts. Go to the gauge cluster, We should see an RPM signal here when I'm rotating it. That seems accurate. Alright, so that works. Now we're going to hook together the ignition coil. Now to explain the wiring. Plug number 1 it goes to ignition number 1. And it just says ignition out. That goes onto number 1 right here. Number 2 here, this is power. It goes to the same switched relay we used to run our Microsquirt that we just set up a little while ago. Number 3 goes to ignition out number 2. And number 4 goes to ground, which in this case I'm running straight to this mounting plate. All we need now is to put a fuse in place, and this should function. So our next step is to check initial timing. That way we make sure that what we assume is top dead center is actually being read and interpreted by the Microsquirt as top dead center. To do this, we have to turn the engine over using the starter. So if you have somebody, a helper, who can get inside the car and turn it over for you while you check it using your timing light, that's great. If you're like me and you don't have anybody like that, then you can create a simple switch like this that allows you to control the starter from out here. And this is very simple. All this does, I'll use some of these alligator clips, some of my favorite things. I've got it attached to power on the green, and then this white wire goes to the signal wire. The white wire attaches to a yellow wire, another alligator clip, and then attaches to the signal wire there. So basically when I flip that switch out there, it tricks it into thinking that the ignition's actually on. So that's going to allow me to turn the engine over while also looking at the light, making sure that the timing is what I expect it to be. Let me get this mounted on a tripod so I can control the switch a little bit better, and then we'll see if it works. She works. Okay, one more very important note. Before we actually turn this over, we're going to have to put a fuse for the igniter. That way our signal light here can actually pick up a signal from the sparks firing. We don't want the engine to start running yet, because if the timing is really fouled up, we could destroy our engine. What I'm going to be doing is taking these plugs out and grounding them to the body. This can still pick up a signal, and we're not going to be firing. There's a thing up here called CAN bus test modes. You click on that, and then you go down to output test modes, injector spark. You click enable test mode. It's going to fire every roughly 200 milliseconds right now. So we're going to start this, and we're going to see if we hear anything. This will allow us to test it without turning the engine over. Oh yeah, don't know if you can see it, but we are definitely sparking. There you go, you can kind of see it. And I've got my timing light hooked up to it, so we'll get a flash too. Boosh. Now what we'll do is turn the engine over using that previous circuit I made, that little switch, and this will flash every time that fires. This is actually getting fired twice. One for the 1 and one for the 4, but it should still work well enough. And what happens is it kind of creates a strobing effect, and you mark on the crank where top dead center is, and every time it flashes it will show you where it is. So if you put it at 0 top dead center, it should flash when it's at 0 top dead center, and that will let us know what the timing is. If it's flashing at like something outrageous, then we can know it because it will show it. Got this zip tied here because this engine shakes violently for whatever reason when I'm turning it over, and last thing I want is this falling into some rotating piece. So that's going to stay there, I hope. Down here we have marked using a white pencil chalk thing. It's not the belt, which is actually what's showing up on the camera more, but this tooth right here, which corresponds to down here, which is top dead center. And also over here there is a, you can kind of see that little white dot way down there. It's not wanting to focus, but right here, right there, that's top dead center. Alright, here we go. Let's see what we get. Yeah, it's firing after top dead center. Probably can't see it, but it's about 5 degrees off. I'm going to change it to 265 in the settings. We're much closer now. We're only a couple degrees off. I'm going to set it to about 263. Yeah, that looks to be it. I'm going to try 262 just to see if I can get it a hair closer, but it looks like it's where it needs to be. And these numbers I'm spouting out, this is the degree offset that we are from the from top dead center, that the sensor is. That looks to be perfect. This guy right here is exactly 262 degrees counterclockwise from top dead center. And it is flashing exactly at 0 degrees. So the next step is to set this to 10 degrees before top dead center for our initial firing. And we'll do this in here. Right now you see we've got a cranking angle of 0. And it's the advance. And you can see our tooth angle right here is 262. So we're going to up this to 10 and then burn it, of course. Burn means you're pushing all this data over to the ECU. Okay, now this is the moment where I get weak legs. We actually are going to start the engine. So this is where things, they should go well. They should. Assuming I don't get hit by a tornado first. We got some crazy nice wind going on out here. Okay, so I'm going to plug in the spark plugs, double check everything, make sure everything's nice and tight, make sure there's no vacuum leaks. I know there was a hose that was attached to the distributor advance that I need to plug. That should be about it. We're actually going to be able to fire it up tonight. So, really all that's left now is to turn the engine and hope she don't blow. Shouldn't. Everything's reading okay. I'm going to turn it over, let it run for just a few seconds, see how she sounds, make sure we still have oil pressure. Because it's been months since I've had this thing running. I've been busy with other things and fiddling with this system and that system and just saving up a little bit of money to buy the parts I needed to do this. So it's completely pitch black in here, so we're not going to be able to see much. But let's see if we can start this together. Let's see what happens. Well, it runs. I've got a horribly squeaking bell. I've got to get that addressed. This takes a half. This is the low range off-road kit. And this alternator really does wonders. It's a great kit. It's a great alternator. Works very well. Make sure we're nice and tight for this. That's tighter. Try number 2. So I found an option in the settings that allows you to fix the timing to a particular value. So I've got that set to 10 degrees right now just for idle. That way I can make sure that it's going to warm up okay and it's not giving it too much advance. I haven't set up the tables yet. Using whatever default values are in there. I probably should have checked that, but I didn't. But the timing was showing up on there between 15 and 20, which is kind of high for advanced. But I noticed when I was listening to this previously, it did have a knock, so it was too much advanced there. So we're going to try 10, listen to it carefully, and if she sounds okay, we'll let it warm up. Right on 10 degrees. Okay, this is the day after, and we have it running pretty well. I did a few small changes, mostly just cleaning up the wires under the hood. I shrink wrapped all the ends, that way they wouldn't be shorting out on anything. And I halfway cleaned up the interior. Still pretty rough. But it's good enough for a drive. The main thing I did is adjust some of the timing. So if we go to ignition settings here and down to the ignition table, you can see that I set max timing at 32 advance, and that's at 3100 RPM. I was reading some forums yesterday looking at the factory manual, and it looks like 30 degrees advance comes on at around 28 to 3000 RPM, and that's the maximum advance, so I went ahead and put that in there. I do have to make all of these be equal to 32 as well. Now this is just rough right now, so what we're going to do is run it like this. We can see if it likes this timing, and then we're going to gradually try and move this over here. I'm going to see if I can move 32 to 2600 RPM. That way I get a little bit more torque lower down. The more timing, the more torque and power you end up getting in general. Burn that. Okay. The engine RPM is a little high right now. I could set that on the idle screw on the carburetor, but I'm happy enough with it for now. So we got enough stuff ready here. I mean, it'll revs pretty readily. Looks like it's keeping ignition, so I'm going to take it on a test drive. Forgot how easy this clutch was. So back. Camera stays in place. Things looking good so far. Not be advanced enough. Not pulling the best. Of course, just never did pull the best. Bad brakes either. Some ignition here to do. Right now it's bogging under acceleration. Looks like it's losing some sync. Yeah, it's losing sync. I'm seeing it here. When I rev it up real high, yeah, there's like a miss. So it's lost 39. That means it's lost count 39 times. While the Samurai did run, it did not drive very well. As soon as I got a load on it, it started sputtering and bucking, and it got sync loss errors. And what it was, the computer was thinking that there was a missing tooth at the wrong location. The best guess I have for that was either too far of a distance between the sensor and the trigger wheel, because there was a good bit of a gap there, or some sort of electrical noise. So we're going to eliminate the first variable with this threaded sensor here. So what we're going to do, the first step, is build a new mounting plate. We're going to put some threads in there. I believe this is an M12, so metric 12. We'll thread that in there, and we'll get it really close to the trigger. So there won't be no big gap like that. So that should take care of that problem. Alright, so here's our old plate. We're going to lay it down onto our 1/4 inch aluminum and kind of make us a template. We're going to cut it about up to here, just a big square. The next step is to mark a location where we're going to be putting the threaded sensor so we can cut out the proper hole. And what I want to do is just eyeball it. So this is here, so we're going to be cutting somewhere in this location there. I'm going to take this, run it right up against the edge if I can squeeze my hand down in there. So now I know my location on both axes. I can take it off and figure out exactly where I need to cut. We can just draw a little grid here, and where they intersect is where we need to put our sensor. So this is horizontal. And they intersect right at this point. So that's where we need to drill our hole for our sensor. We had to drill a couple more holes up here on the top because when I put it in, the sensor was slightly offset from where I wanted it to be. But the most important thing is that now the Hall effect sensor, when threaded in through here, lines up perfectly with the trigger wheel. What we need to start working on is wiring up our threaded Hall sensor here. Now this one doesn't have a pull-up built-in, so you gotta install this too. The way this works is brown, it's kind of tan looking wire, goes to pin number 2, which is this red one, that's power. Black is output, that goes to pin number 3, which is actually this blue one. And in between these two, right on the edges, I'm going to solder this resistor in. And then finally, the blue wire, which corresponds to black on here, is the sensor ground. Got our plate mounted and our threaded sensor in there nice and good. I got a map sensor from Rock Auto. Wasn't supposed to be here till later next week, but it arrived very early, so I'm tickled about that. So while we're waiting for that to get done, we can go ahead and wire up the electrics for this guy. Now what the MAP sensor is, it's manifold absolute pressure. It plugs in to a vacuum source onto the intake and allows the Microsquirt to determine engine load, and we can set up spark timing based on that load. So aside from the vacuum source, which goes right here, there are 3 prongs on the inside which correspond to the 3 prongs on this pigtail. And the camera probably won't focus, but it says C, B, and A. Now C, which is furthest on the left, that goes to our VREF. That will be our power source, 5 volts. B is the MAP input to the Microsquirt, and A is sensor ground. Alright, we're running. Pretty smooth. It's actually the least shaky the engine's been in a long while. I'm not exactly sure why that is, but it is. The MAP gauge is reading properly. I'll take you in here and show you what all we got currently. Okay. So far we have no sync loss issues. Alright, here we are. Engine map. Give it a little bit of throttle, it'll go up real quick and then down. See? Up and down, up and down. It also goes to the fuel load, but we don't have no injectors hooked up, so nothing there. So far, no sync loss. Engine advance is set at 10 degrees. We'll let her get warmed up, and then we'll look into building our map. Alright, so we got our table set. I'm probably actually going to have to inverse these values. So I thought a low engine load would be down here and a high engine load would be up here, but it appears to be opposite of that. So really the 32 should be up here and the 28 should be down here. We're going to give it a little bit of revs lightly and see what we get. And actually, I want to start a data log too. Alright. I think we're going to be okay. We might be able to actually take this on a road for a quick drive now. Cool, cool. Past me. Something I get fairly used to. No sync losses yet.
tires feel a bit loose though. The suspension in this is a lot more loose than in my Fiat, which is what I'm used to. Put a bigger steering stabilizer on this sucker. So far so good. Something really strange in the drivetrain. We're not getting any sync loss issues. That's what I was concerned about. Most likely, all these things I'm feeling is just stuff that's always been there. I just haven't driven this thing in so long. Hope so anyway. I hope the tires and the drive shafts are getting ready to fly off for me. I think I'm watching my catastrophic failure with me. This feels a lot better than the first run I had, which I didn't make it very far on the first run, but it had a lot less juice than this does. Put new shocks on this, but it's still rough with these bumps. muffler on this. I've got a 12-inch glass pack. It might be 24-inch. Deadened the noise a lot compared to what it was, but it's still pretty noisy in here. The engine and the tranny makes a lot of noise just in and of itself, so it wouldn't be a bad idea to do that. Boy, the steering is vague, look at that. put discs all the way around on this thing though. Talking to each other up here. Well, let me through. The highway. We're almost to 50. There we are, 50 miles an hour. Oh hey, the camera cut out before we made it back home, but we made it back home. Check it out. No sync loss issues. Everything is running nice and smooth. Well, that's it. Thanks for sticking with me. I'll see you another time.